Welcome to marvyteach. Today we'll be looking at bonding. Bonding is something that all elements have to go through, and then want to know why they go through it, types of bond that exists, and why they go into all those bonds. We'll be looking at today. For an atom to exist or an element to exist, they have to be in a duplet state or an octet state, where they're regarded as noble or perfect. Some elements naturally have that state that are called noble atoms. For example, neon, helium, that have a duplet state or an octet state in their nature, in their valence shell. When you have either 2 or 8 in a valence shell, you're known to be a duplet shell, or a duplet state or an octet state. And all elements have this as a vision to get, and that is why they go into bonding. Before we go all there, let me just tell you why they bond and what happens when bonding occurs. Now, as I said before, an element like sodium wants to have 8 or 2 in its valence shell, but the electronic configuration of this, according to the KMN, is 281. According to the KLM shell configuration, KLM. This 8 not B, haha. K8. Let me clean that off. Grab that off and write it again. 2, 8, 1. This is sodium, no one, forget that. Okay, now we have this 281 KLM. Now this has to have either 8 or a 2, but 2 has already been gotten, so it has to have 8. The first shell is already complete 8, but the third shell is not, and then it has to either gain 7 electrons or lose this 1 electron for it to have 0 here, and then this has to be complete. I'm sure you get that. So what really happens with sodium is that this goes away to an element that needs it. Let's keep it in R for reserve, electron reserve. Let us put it that way, electron reserve. Okay, now this one electron is already there, and don't forget that the number of protons in neutral atoms equals the number of electrons, and this P is equals to N. The neutral atom like this sodium now. But when this occurs, the number of protons, not N, sorry, E. The number of protons exceed the number of electrons. In this case, that is why sodium becomes positive. How? When this one goes to the electron reserve, as I've said before, this electron reserve is imaginary though. We'll use it as an explanation point. Now this goes there, and then this is normally 11, and this 11. But when 1 electron from the valence shell leaves to electron reserve, this becomes 10 because 1 has gone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 8s. So it's going to be 10. Therefore, more positive charges and negative charges, and then this becomes positive as a whole. And that is where sodium gets positive charge. In some exams, you may see how does sodium cation look like, how many what is the valence states or something like that. That's only +1. And this is what happens to all the metals that go into ionic bonding. We'll go to ionic bonding later, but for other elements or other metals, yeah, like magnesium, aluminium, this loses 3 electrons. Yeah, magnesium loses 2, aluminium loses 3 electrons. So this has magnesium 2+ and aluminium 3+ respectively, and that is how metals exist. Not exist, but when one's going to do some type of bonding, they go like this in form of cation. What's a cation? The cation is an ion that has a positive charge, a group of atoms that have positive charge, or an element that has a positive charge, like sodium plus magnesium plus 2+ or aluminum 2+. Now this is what happens for metals like sodium, potassium, lithium, magnesium, aluminium, so much more. But for non-metals, they don't lose electrons, rather they gain or they share. Sharing is kind of general, but non-metals, especially electronegative ones, actually gain electrons. For example, element chlorine. Chlorine. How can I find chlorine? In chlorofluorocarbons like freon, chlorine is found there. And many more compounds. Purple sodium chloride, chlorine is found there. Copper chloride, cobalt chloride, chlorine is found there. Now, this chlorine has atomic number 17. 17. Using the K element shell configuration I've been using before. K, L, M. Find out that it's going to be 2, 8, 7. Now, chlorine has a choice, or Mr. Chlorine has a choice, whether he has to take all these chlorine electrons out, but that will cost him a lot of energy, or he just collects one electron from the electron reserve and then it's complete. So if you're Mr. Chlorine, I think you'll have chosen to get one electron because it's easier for you. Unlike some people that will say, oh, they want to lose one, or just lose the 7 of them, when you can easily just gain one and everything is done. And that's what Mr. Chlorine does. As I've said before, number of protons is equals to number of electrons, so P is equals to N. In this case, or P is equals to E. In this case, 17, 17. But for the electron reserve, the imaginary one, this comes here. Right? The one that sodium donated before comes to this place. And this becomes 8. 8. At this point, it has gone to or attained a perfect state. In chemistry words, not layman language, chemistry words, you say it has attained an octet state. Then electrons now become more than protons. It becomes 18 electrons and protons still remain at 17. So chlorine as a whole now becomes -1. I think you understand that. Very easy. That is why they, have charges. And negative charges are called anions. Or negative, all known as anions. So where Cl is minus and sodium is plus. Now I thought about magnesium and aluminium in the metal part. And in the negative part, I'll tell you, well, oxygen I breathe in and breathe out. When you want to form an ion, it goes as 2 minus. That's 2 in the outer shell. 6 in the outer shell. Now gets 2 in and then becomes 2 minus. And that's how that goes. Yeah. So let's clean that up. Let's clean that up. Now, there are mainly 3 types of bonding. Or should I say 2? Yeah, 2. Ionic and covalent. But before all this, before all this we have intermolecular and intramolecular. Intermolecular is bonds between molecules of the same compound or the same element, like van der Waals forces, dipole forces, hydrogen bonds, etc. While intramolecular is the bonds between atoms of different molecules, atoms of the same molecules. For example, covalent, as I'm writing here, covalent and ionic. Okay, let me clean this, not looking fine. But ionic and covalent, yeah. Now, there's books you may see electrovalent instead of ionic. So this could also be called electrovalence. 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 Sorry for the break. Sorry for the disturbance. Electrovalence. Yeah. So. Okay, I think we know the name. Let's write that again. Okay, now. Covalence is basically sharing of electrons, and covalence is basically sharing of electrons, and ionic is the force that occurs between a positive charge and a negative charge. We'll do ionic first, then covalent. Under covalent, we still have dative or coordinate covalent. That'll be for another day. You can still do it now. And then after this, we still have one more. And we have metallic bonding. That will come immediately after the ionic. So let's face ionic for now. Ionic bond is the bond that occurs between the metal and non-metal that have different charges, especially plus or minus. The electrovalent bond is the transfer of electrons from the metal to the non-metal. Now let me do this in a diagrammatical way. For example, Mr. X plus and Miss X minus. At some point in time, they were both like this, no charge, but they were not perfect. They were not in a noble state. So what happens? This loses an electron to become positive, and this gains that electron that was lost to become negative. Now let me use particular examples like sodium and chlorine. I'll draw the bonds for you, and then you see what really happens. Okay, now let's go. Sodium 2 here, then 8, then 1, right? Then and chlorine 2, 8, okay, 8. Here we have 7. I've said before, this is sodium, this is chlorine. What is the magic that happens here? Okay, look at it. First of all, the sodium says, oh no, I have too much, I need to get an octet and I have 1 extra electron. So I think the best I can do is just give it out, and then I'll be free from all this stress. Then Mrs. Chlorine is like, oh, I need 1 electron, and then you have 1 electron. So let's just go into a bond together, and then you give me 1 electron, I accept an electron, and we sit together. You understand? No. So let's do it like this. Okay, Mr. Chlorine says, I have 1 electron, yeah. So the best thing I can do for myself is to throw the electron away and I'll be free. But he can't, because he cannot leave an electron in the atmosphere. So he has to give another element that needs it so that it can become octet, and that can also become octet. Now chlorine is like, I have 2 choices: lose my 7 electrons or gain 1 extra electron. And I chose to gain 1 extra electron. So that extra electron that's from you, I collect it. So what happened is this sodium, this sodium gives this electron to Miss Chlorine, and then this 1 electron now comes here. This becomes 8. This becomes octet. This becomes octet. Okay, so this requires less energy to give this, and that is what it chooses. So let me map already, and at this point, sodium becomes plus, as I told you before. Sodium becomes plus, chlorine becomes negative. I think you now know how this happens. And then this bond between this positive and this negative is what is known as ionic or electrovalent bond. I think very clear. And the chemical formula is sodium chloride, table salt, Epsom salts. Different names, but it also means one thing: sodium chloride. Okay. Let me ask, how does this happen in other, for example, magnesium? Magnesium has 2 in the outer electron, and it needs to give out these 2. So what Mr. Magnesium does is gives 2 away to maybe chlorine, and then magnesium. So plus. Okay, chlorine cannot collect 2 because it can only collect, that's space for only 1 electron. So chlorine calls the bond is going to stay the same. So there will be 2 chlorine, 1 magnesium. Now share the electrons equally. You take 1, you take 1. Take 1 too. So this becomes -1, -1, and magnesium is 2 plus, because it has to give 2 of it to this. Same thing that calcium does, another element. Now, the chemical formula of magnesium chloride is MgCl2. Magnesium Cl2. And write it down. MgCl2. Let's see here, because 1 magnesium gives 2 electrons, or 2 chlorine, 2 different one different electron, making it 2. The chlorine needs 2 of itself to get 1 magnesium. That's why MgCl2. And then the increases to aluminum chloride, that is AlCl3. AlCl3, because aluminum is Al3 plus in cation state. So chlorine needs 3 of itself to collect 3 different electrons for them to become an octet state. That'll be all for today. We'll see you next time for covalent bonds. Thanks for watching. Invite your friends. Subscribe to our page on Facebook, on YouTube. On Facebook we are marvyteach, and then on YouTube you can see the Dollar Polymer World for marvyteach learning. Everyone you see, subscribe, and you'll learn more. So your friends about it, teachers about it, still everyone I know about it, the parents, everyone. Then you can gain more. Thank you.